Okay, problem 2. So in this problem we want to design an algorithm for the president to basically give some shares to 100 generals in the military such that not any 9 of them can launch the missile, the nuclear missile. So not 9 generals can be able to get the secret key, but we can think of 10 truthful generals to be able to launch the missile. On the other hand, we have 5 spies. So these spies, we don't know who they are, and they can give incorrect information. So they can basically give incorrect values for their shares, which might be problematic for launching the missile. So first, let's see what the degree of the polynomial that we want to use should be. We have the fact that 9 generals cannot launch the missile, so the degree of the polynomial should be exactly 9. Because we know that if we have 10 points, there is a unique degree 9 polynomial that passes through those 10 points, and if we have 9 points for this polynomial, basically they are not able to get the secret key. So we give the shares P of I to general I, so I should vary from 1 to 100, and the secret key can be P of 0. Secret key is P of 0. Therefore, if 10 truthful generals come together, they can find P of 0. Now we want to find what number n should be the total number of generals that no matter how many spies are them, we are sure that if they gather, they can launch the missile. So we claim that this n should be 20. Why? Because the spies are basically like errors in error correcting codes, and we have 5 spies that give incorrect information. So if 20 generals gather, we have at most 5 spies among them. So when we have at most 5 spies among the general, it is like we have 20 points with 5 errors. So we remember from the lecture that if we have m plus 2k points, we can recover up to k errors. So here we want this n, you shouldn't be confused, this n in this problem is basically the m plus 2k in the lecture. So if we want to find m plus 2k, and k in our problem is 5, and n, so let me call this m plus 2k, and m here is 10. So indeed we need 10 plus 2 times 5 equals 20 generals together, such that even if 5 spies are among them, they can still both find who are the spies and they can launch the missile, similar to the algorithm that we use for error correcting codes in the lecture.